Okay, folks, this is a short little like introduction or drawing of angle, side angle, and side angle. This is really 5.6, okay? We got your reading in that and everything, but it's all about this picture. So what I'm going to do is I'm going to take my ruler, the golden rule. Okay, get it? You know what the golden rule is? Hey, look at that. Do unto others as you would have them do unto you. Well, anyway, so I'm going to make a uh, bottom of a triangle. How about we do 4 inches? No, 3 inches. 4 inches. All right, let's do 4 inches. All right, all the way over here to 4. Okay, you with me? So here we go. We got, how about A and B? Okay, now let's see, because we're going to do two triangles, so I'm just going to go over here, do the same thing, 4 inches. All right, 4's right here. Okay. All right, so how about we call this DE, okay? See, I can't ask for people for letters because, hey, we're not in the classroom. All right, now, what I want to do is I'd like to put this vertex right around here somewhere. Whoops, sorry about that. I'd like to put that vertex like around there somewhere. So I'm going to come up with an angle here. All right, so we got the gun, the barrel, right? Okay, so I'm going to just pick an easy angle measure. Hey, 30 looks good. So I'm going to go 30 degrees. I'm going to go over here and I'm going to put an angle 30. Okay, now I'm going to go back over on this side, okay? And I'm going to pick an angle, how about 60? See, 60 is a nice, even angle. All right, so okay, now remember, this was 4 inches. This was what, 30 degrees, and this was 60 degrees. By the way, what would that angle be there? I don't know. That's just an interesting side light. All right, now we got to go to the other triangle. Okay, so remember, this was 30 degrees. Got to line it up right. 30 right here. I like to put it right there. Okay, 30. Okay, 30. All right, 60 right here. Okay, you gotta be particular with these things. Now, here's this question. So, right, this is 4 inches, this is 30 degrees, and this is 60 degrees, correct? Correct. Shake your head this way. Now, the question is, are these two triangles congruent? Good question, right? Well, let's see, could I put this one over that? I don't know. Can you see that? Let's turn the light on here. Hello. Okay. I don't, you may be able to slowly see it. I don't know, it's kind of hard, okay? I could try to do that. Another thing we could do is just cut one of these out. So, hey, I got an idea. Let's just cut this one out. Now, remember, like I said before, I can't cut up, but I can cut forward. So I'm going to go like this. Voila. I'm going to go voila again. Okay, and I got to cut this side out. Okay, got to be, you know, it's hard to be very accurate, okay? But when someone's building your house or building your car, you want things to be accurate, don't you? Why? Because you want them to work. Okay, so, right, I have A, B, and what do we got here? C, correct? Okay. Now let's go over here. What was this? This was D, right? E, and F. Okay, so here's the question. Is triangle ABC congruent to DEF? Oh, that's a good question. Now, what do we know already? Hold on, I could get my red pen. I got to pause the thing. Okay, so I got my pen. So we got that side, right? Okay, what else we got? We got this 30-degree angle. And we have what? We have this angle, right? Okay, now, are the triangles congruent? Well, we're talking just this pair, right? Okay, well, if I move this guy and put it right over, I'm talking right on top of. Well, y'all, that is pretty close, my friend. Okay, so what do we have? We have another way of proving triangles congruent. Okay, and it's called angle side angle. Angle side angle. All right, that's very important. Now, why are we doing this? Why are we doing this? We're doing this, number one, to help us know about the world around us, help us to be able to prove things, help us to be able to think. You may not build the bridge, but you'll understand more about the bridge after you know more, okay? You may not understand how your house is built, but at some point you may have to repair your house, so that would help, okay? All right. So, your book goes through a proof. What they do is they go, let's see, I've got these two triangles here. Let's put, I think what they did is they said, let's put these guys together like that. Then let's rotate this around here. Actually, rotate it like that. And then you notice that if you reflect this across here, it's going to be right on top of that because angles are preserved. This is a rigid function. That's the way of proving it, okay? They're trying to prove it for all possible ASA. All right, so anyway, that's the lesson. But there's another part. Oh, no. I know. It's called SSA. Be careful how you write that, okay? Now, what that's saying is if I have two triangles, now I know two sides, hold on, I know two sides, but not this angle, right? Because that would be side angle side, okay? Remember, all these are acronyms or shortcuts for the way of proving triangles congruent, okay? All right, so let's see, but this is SSA. So SSA. SSA. No, that doesn't work, okay? You cannot do that because, see, you could easily move this side up this way, so SSA does not work, okay? So actually, I wrote that wrong. It should be side angle angle, but that's okay. So let's get a piece of paper out, okay? All right, here we go. So side angle angle, side angle angle. All right, let's do that again. How about we do it different here? This time we have it obtuse triangle, okay? A little overweight there, whatever, okay? All right, so here we are. Now, angle, angle, side. Angle, angle, side. See? Can I prove those triangles congruent? Good question. Well, watch this. Isn't this third angle theorem? Doesn't that say if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent? Yes. Yes, they are. Shake your head this way. Okay. All right, so that's how that works. Really, isn't that a version of angle, side, angle? See how I oriented the paper so you could see angle, side, angle quicker? Okay, that is how that works. So conclusion, okay, we know what? We know SAS, we know SSS, we know hypotenuse leg, we know ASA, and then we have another one, which is a version of ASA. It's called SAA or AAS. Doesn't matter how you write that. Okay, so hopefully that drawing helps prove it to you. Thank you for paying attention and watching it.